Hello and welcome to a screencast about the inferred properties of Earth's interior. You're going to be looking at page 10 in your Earth Science reference table. So turn to it and let's get started. The information is organized here. You can see that you have kind of like a slice of Earth where you're looking from the crust of Earth towards the interior of Earth. Then you have your properties like pressure and temperature. The first thing that we're going to look at is how this top part of the graph is broken up and what information it has to offer. So we're going to start from the outermost layer of Earth and then work our way in towards the inner core. There's a lot of information here, but it's not that bad to read. So let's start with right here. You see you have Atlantic Ocean, North America, Pacific Ocean. And this might help you with locating features, like in the Atlantic Ocean, you would have the Mid-Atlantic Ridge. That kind of makes sense. Okay, and then later we're going to talk about trenches. And we have the Pacific Ocean over here, and there's a trench over there. Anyway, so let's start with the outermost layer of Earth, which we should all be somewhat familiar with. The outermost layer of Earth is the lithosphere. So we have the lithosphere, which is the outermost layer. Now the lithosphere is made of both the crust and the rigid mantle. We're just going to start with the dark black line here, which you can see that this is pointing to the dark black line, and it says that it's the crust. So that's that dark black line. Now when you follow it up over here, it will tell you the density of the crust. So we have two types of crust. We have continental crust and oceanic crust. So our continental crust, it tells us the density of it is 2.7 and that it's primarily granitic. So it's primarily made of granite. Igneous rock. Then we have our oceanic crust, and we have the density of it, which is 3.0, and it's primarily basaltic. Again, another igneous rock. Then we have this white space, it looks like below the dark line. You have this white space here. This is the rigid mantle. So it's the beginning of the mantle. So that, again, it's a very narrow space here in between. This is the rigid mantle. Okay? If you notice right here at the bottom of the dark line, where the dark line meets this white line here, they call that the MOHO. So that is your MOHO boundary. It'll become important as we go into the interior of Earth and plate tectonics and things like that. But you have your MOHO boundary. You'll definitely see questions on this. Okay, so after our rigid mantle, if I can speak, our rigid mantle, we have the next part of our mantle, which is called the asthenosphere. If you look, it says plastic mantle. This is really important because it's a solid that acts like a liquid. It's close to the melting point, but it's not melted rock. Okay, it's solid rock that's extremely soft. It acts like a liquid. This is why we have these arrows here that show us that there are convection currents in the plastic mantle. So you can see your warm plastic mantle that rises. As it rises, it cools, and then it sinks back down over here. These are also showing convection currents in our asthenosphere, the plastic mantle. Right below the asthenosphere, we have the stiffer mantle. Now this is not, convection currents are not occurring in the stiffer mantle, hence why it's called the stiffer mantle. If you were to look at the densities from the plastic mantle to the end of the stiffer mantle, our densities are 3.4 to 5.6 grams per cubic centimeter. All right, now in our journey to the center of Earth, we have the outer core. And you can see the outer core, it says that it's primarily made up of iron and nickel. Now we know that the outer core is actually liquid. And when we get into more detail, we'll describe how we know it's liquid. It has to do with seismic waves, and that's a hint. Anyway, when you look at that, again, down your column here, you have the density of your outer core, 9.9 to 12.2. Then we go to our inner core. Again, made of iron and nickel, but unlike the outer core, this is actually a solid layer, and the density is 12.8 to 13.1. So that's just the beginning of what we're looking at on our table. Next on this chart, this table on page 10, we start to look at the different pressure that exists in the different layers of Earth. As you go deeper into Earth, there is more pressure because there are more layers on top. So this graph here tells you just how much pressure is at each layer. The pressure is measured in millions of atmospheres. So you'll see you have 1 million atmosphere, 2 million atmospheres, 3, and 4. This is your graphed line here, and you'd read it just like you'd read any other graph. It corresponds with the layers here. So if I were to ask you what is the pressure at the interface between the stiffer mantle and outer core, I would follow this straight down to my graphed line, and I would say, okay, the pressure there is 1.5 million atmospheres. If I said, what is the pressure at the interface between the outer core and inner core, you again follow that interface straight down. There's a dotted line to help you, which is convenient. You would say it's about, I'd say 3.1 million atmospheres. Again, I'm estimating here. The least amount of pressure, obviously, is the surface of Earth, where you have 0 million atmospheres because you're on the surface of Earth. As you get deeper into Earth, the pressure increases. Finally, we have this bottom graph here, which again corresponds with the layers. You have dotted lines that you can follow it down. This is where we read the temperature of the interior of Earth. So the temperature is measured in degrees Celsius, and then you have your depths here, which are in kilometers. This dark line here that says interior temperature, this dark line is the graphed temperature of the interior layers of Earth. So let's look. Obviously the coolest temperatures are at the surface of Earth. If you follow this down, you see the coolest temperatures are towards the surface of Earth. As you get deeper into Earth, the temperature increases, the hottest temperatures being at the inner core. Now this part of the graph also allows you to gauge depth. So if we were looking to find out what the depth of the outer core, well, where the outer core begins, we would look at the outer core, follow it straight down, and we know that we have a depth of about, it's not at 3,000, it's about at 2,900. It's right before 3,000. So I'd say 2,900 kilometers. Then if we were going to look at the temperature at the depth of 2,900 kilometers, we could again follow the outer core down, and I would say the temperature is about 5,000 degrees Celsius because I'm following it down to my graphed line here at the beginning of the outer core. If we were looking at the interface between the inner core and outer core temperature, again, we said the depth is about 5,100 kilometers, and the temperature I would say is about maybe 6,300 degrees Celsius because that's where my graphed line is. Finally, we have these dotted lines. These dotted lines are labeled as the melting point. These dotted lines represent what the temperature would have to be in order for the rock to be melted. So we're looking at this graph line. You can see the graph line kind of meets the melting point line right about here. And it says partial melting, which if you remember, we said the asthenosphere, the plastic mantle, has convection currents. It's a solid that acts like a liquid. So it's not liquid, and if you follow the asthenosphere down, you'll see that it's right at the melting point, but it's not melted. It's only partially, it says. Again, that's why it's a solid that acts like a liquid. Here again, we have a continuation of a dotted line, again, the melting point. Take a look at the outer core. When you follow the outer core down, you can see that the interior temperature of the outer core is above the melting point, which tells me that the outer core is actually melted. It's a liquid because its temperature is above the melting point. Finally, as you go towards the interior, right here in the inner core, we can see that the temperature of the inner core is below the melting point, and that means that the inner core is a solid. Okay, well, I hope this helps you read page 10 of your Earth Science reference table.